Ion, welcome to the course of Applied Mathematics. Our course consists of two parts. Part 1, linear algebra. In Vietnamese, linear algebra is đại số tuyến tính, line linear. You know the equation of a line ax plus by plus c equals 0. So we consider function a1 x1 plus a2 x2 plus etc. plus an xn equals b. This equation is also called linear. Linear means power 1, power 1, power 1. Okay. So linear algebra in Vietnamese đại số tuyến tính, tuyến line. And part 2, analysis. Analysis in Vietnamese is giải tích, not phân tích, giải tích. And in part 1, we have lesson 1, matrices. Matrices. Lesson 2, determinant. Lesson 3, system of linear equations. System of linear equations. And lesson 4, economic applications. For lesson 1, matrices. Lesson 2, determinants. Determinant from the verb determine, xác định, determinant, định thức. System of linear equations, power 1, and economic application. Part 2, analysis. Lesson 1, single variable function. Single variable function. For example, you know y equals the function of x, one variable, x. Derivatives and differential. Derivatives đạo hàm, differential vi phân. Extrema, maximum, minimum. And economic application. Economic application, marginal elasticity. Okay. listen to two variable functions, two variable, not 3, not 4. In this lesson, we consider partial derivatives. Partial derivatives and total differential. And extrema of two variable function and economic application. For example, we will find maximum of profit, maximum of revenue, minimum of cost. Lesson 3. Differential equations. Variable separation method. Variable separation. And first order linear differential equation. First order. We don't consider two second order, first order. And application. Okay. So our course consists of two parts. Part 1, linear algebra, đại số tuyến tính. Part 2, analysis. Now the lesson for today, matrices. Matrices is an array of number, for example, of parameter or variable. This is called a number. This is called parameter. And this is called variable. Okay? It's an array. And we denote A, capital A, number of row 2, first, times number of column 3. Capital A, 2 rows times 3 columns. And we denote elements of this array. For example, A1, 3, row 1, column 3 here. A2, 1, row 2, column 1. here. So we have A, I, J, I column, sorry, I row, and J column. Row first, then column. Okay. And we call dimension of the matrix A 2 times 3. In general, M times N, M rows, and N column. Okay. Row first, then column. For example, given A3 times 4 equals 3 rows, 4 columns. One, 0, 2, minus 3, 0, 5, 4, 6, 7, 8, minus 1, 2. You can enter this matrix in pocket calculator. Mode 4 matrix. Define matrix. We choose mat A number 1 and number of rows 3 rows. Number of columns 4 columns. We enter 1 equals and we move the next position 0 equals, etc. And we press AC for cell. Okay. Number 4 matrix. Define matrix mat A. Number of rows 3. Number of columns 4. And we enter each element from the left to the right and from above to below. Then we press AC for cell. Now we have A1, 3 for example. Row 1 and column 3, row 1 and column 3 here. A2, 1, row 2 and column 1, row 2 and column 1 here. Okay. Now we consider about some special form of matrices. Special form. Square matrix. For example, given A3 times 3, capital A3 times 3, 3 rows and 3 columns, 1, 0, 4, minus 2, 5, 6, 8, 7, 10. You know that the number of rows equals the number of columns. Number of rows equals number of columns. This matrix is called square. And this diagonal is called main diagonal. Main diagonal. And the other diagonal is called sub-diagonal. Okay? Square matrix, number of rows equals number of columns, and main diagonal from the left above to right below it. And the other diagonal is called sub-diagonal. Now upper triangle matrix. Upper triangle matrix. For example, given A 4 times 4. First, we know that this is a square matrix, square. Number of rows equals number of columns. So we have diagonal, main diagonal, and below the main diagonal are on zeros. A and N square. Zero. All elements below the main diagonal are zero. Okay? And similarly, we have lower triangle matrix. First, this is also a square matrix, and above the main diagonal are on zero. Okay. For example, all elements above the main diagonal are on zero. All elements zero. Now consider about diagonal matrix. Diagonal matrix. For example, given A 4 times 4. 4 times 4. For example, 1, 0, 0, 0 minus 2, 0, 0, 0, 1. You can see on element out of main diagonal 3. On element out of main diagonal are on 0. Out diagonal are on 0. Okay. This is called diagonal matrix. Now we consider about identity matrix. Identity matrix. For example, 1, 0, 0, 0, 1, 0, and 0, 0, 1. You can see this is a square matrix. First, this is a square matrix, and on elements on diagonal matrix are 1s, 1, 1, 1. Square matrix out of main diagonal are on 0, and on elements on diagonal matrix, main diagonal are 1s. Now we consider about matrix operations. Matrix operation. Matrix operation. Okay. Number 1, equality. Equality. A m times n is equal to b m times n, equivalent to A I J equals B I J for all I from 1 to m, 1 to m. Number of rows was m, so we have m rows, row I from 1 to n, and j equals 1 to n. We have n column, so the column j from 1 to n. You know that dimension of A and B are equals m times n, m times n. Similarly, for vectors, the dimension of a vector and the other vector are the same. Okay. And for example, consider two matrices here and here. We have the dimension of this 2 rows, 3 columns, 2 rows, 3 columns equals the same, but 4, different from minus 4. So, different from. Okay. We have two matrices are equal if and only if for on I and for on J. This is not for all, because this element now we consider our addition of two matrices A plus B. You know that dimension of two matrices are equal, the same dimensions, equals also an atomic matrix C M times N equals a matrix of the same dimension, where elements of C of the result C, I, J are obtained by A, I, J, the same position, plus B, I, J, the same position, I row in J column, I row in J column, I row in J column for on I from 1 to M. Here we have M rows and J from 1 to N. We have N columns, okay? For example, calculate 1, 2, minus 3, 0, minus 1, 5, plus 1, minus 1, 2, 3. Here, the dimension of two matrices are not the same. So, mark error. Okay. We only add two matrices of the same dimensions. Here, not the same dimension. Example, calculate minus 1, 4, 5, 0, 1, minus 2, 2 rows and 3 columns, 2 rows, 3 columns. Okay. Here, two matrices have the same dimensions. 2 times 3. So we can calculate addition. We can add two matrices. We have this position plus this position 1 and this plus this 2 and this 5 plus 3 8. Okay, the same position. 0 plus minus 1 minus 1 1 plus 4 5 and minus 2 plus 6 4. We add two elements of the same position of two matrices. Okay, the same position. Now we study about properties of addition of two matrices. A plus B equals B plus A. This law is called commutative law. Commutative. And A plus B and plus C equals A plus B plus C. Associative law. Associative law. Okay. Commutative law. Associative law. Commutative and associative. We do this operation first, then we do this operation first, then now number 3, scalar multiplication. Scale. K, a number, times A matrix. M rows and N columns. The result is also a matrix of the same dimension. A number times a matrix M by N equals a matrix of the same dimension, where elements of the matrix B, VIJ equals K multiplied by elements of A of the same position, IJ. VIJ equals K AIJ. For on. Row height from 1 to M. Here we have M rows from 1 to M. And for on J from 1 to N. Here we have N columns. Okay. So if multiply a number and a matrix, we have a matrix of the same dimension. For example, compute 2, 1, 4, minus 6, 0, 5, minus 2. 2 times 1, 2 times 1 is 2. 2 times 4 is 8. 2 times minus 6 is minus 12. 2 times 0, 0. 2 times 5, 10. And 2 times minus 2, minus 4. It's very simple. Okay. We make multiplication of each element of the matrix. Okay. For example, compute 3, 0, 6, minus 1, minus 2, 3, 4, 1, 0, 6, minus 2, 1, 0, 0, 3, 5, minus 6, 0, 4, 5. Now, we make the operation of each element of two matrices. Here, 0. Here, minus 2 is minus 2. Okay? Row 1, column 1. Row 1, column 1. We write on row 1, column 1. And here, row 2, column 2. 18, 0, 18. Okay? Here, minus 3, 0, minus 3. Minus 6, minus 6, minus 12. 9, minus 10, minus 1. 12, 12, 24, 12, 12. 3, 0, 3. 0, minus 8. 18, minus 10, 8. Very, very simple. Okay? So we compute this element of each position of two matrices. We compute each element of the same position. Now, some properties K, I, K, A plus B is Ka plus Kb. This is called distributive law. Okay. From the left, K plus L minus K plus L times capital A. KA plus LA distributed from the right, from the left. And associative law. We do first step. On the right hand side, we do first step. Associative. Okay. Very, very simple. Similarly, we have these properties. Is the same with number. Now number 4. This operation is very complex. Multiplication of 2. Multiplication of 2 matrices. Okay. We have matrix capital A M times N multiplied by B N times B. We know that the number of columns of the first matrix is the same to the number of rows of the second matrix. And the result is a matrix of dimension M times B, and here, and B here. The same. Okay. And M, P are arbitrary. Is can the same or not? M, P. Where elements of the results CIT equals AI1 row I column 1 B1J column J row 1 B row I of the first matrix and column J of the second matrix column row plus the next element I2 second element B row 2 column J plus AI2 B2 J plus etc. Row I column N row I column N row I B N J column N row N plus AIN times BNJ. So we know that the number of elements on ith row N equals to the number of rows on column J of B. And we can do this operation. So if n different from n, here the number of columns of the first matrix different from the number of rows of the second matrix, we have math error. Okay, the number of columns of the first matrix, number of columns. The number of rows of the second matrix, number of rows, are equals. And we can write sigma we know sigma in quick in legend as sigma. As for sum, okay, in Greek we have sigma, the same in legend as sum. So we can write the formula sigma A I row K column K times B K J. I row here and J column here, row column, and K from 1 to n. This is the sum of, we substitute K1, I1, 1K, sum plus A, I, K, the next 2, 1, 2, B, 2, J, etc. A, I row, and times B, K, and J. Okay, we can write this formula. Now we practice this operation. For example, given A, 2 rows, 3 columns, 2 rows, 3 columns, 1, 0, minus 5, minus 2, 3, 6, 2 rows, 3 columns, times B, the same, okay, 3 columns, 3 rows, 4, 1, 2, 6, 0, 4 columns, minus 1, 0, 3, 4, 3 rows, minus 2, 1, 0, 0. The number of columns of the first matrix equals to the number of rows of the second matrix. We can find A 2 times 3 multiplied by B 3 times 4, the same. and we have a matrix of dimension 2 and 4. 2 rows, 4 columns. Okay. The row is the row of the first matrix. The column of the result is the column of the second matrix. Now, here, first column, first row, first column, first row, first column. We can compute by pocket calculator. 1 times 1 plus 0 times minus 1 plus minus 5 times minus 2. You can use your pocket calculator. 1, 0, 10. We have 11. Okay. First row, first column. In a secondary school, we call this is inner product. Inner. A vector and a vector. We multiply 2 elements plus 2 elements plus 2 elements. Okay. 1, 1, 1. 0, 0. Minus 5, minus 2, 10. Okay. And here, first row and second column, first row, second column, inner product. 1 times 2, 2. 0 times 0, 0. Minus 5 times 1, minus 5, minus 3. Okay? You can practice at home. Row, column, inner product.